For the next part, let us make a silly tiny change in the layout that we have already built. I'm going to draw the output metal wire to an extremely huge length and see the effects on the working of the inverter. So why are we doing this in the first place? As we discussed in the previous video, wires contain parasitic resistances and capacitances that slow down the transfer of input to the output. So it's nothing but an exaggerated implementation of parasitic from the inverter. So what I'm going to do is move the output pin to an extremely farther distance compared to the previous position. So now that I've placed my pin in a farther position, I'm going to make a wire that is extremely long and connected to the output. Now the connection is the same as before, but the only difference is that now the output wire is extremely long. Now I'm going to save this design, and then I'm going to make sure that my layout is still correct based on the design rules and it matches with the schematic. So there are no errors found. And similarly, I'm going to perform LVS check as well. And it says that the schematic and layout match. So our design is correct, but the only difference is now we have a long wire with high parasitics. So now I'm going to go back to my library manager window and then go into test bench and configuration to simulate this new layout. So we have all of the settings already done in it. So we can launch the ADEL window and then do our usual setup. And then I can run it. And now, if we can zoom in, on this part, you can see that the delay is much more than in the previous case. The drop is gradual. The transition between bit 1 to 0 is much more gradual than in the case with the short output wire. So this means that the parasitics affect in a way that the output switches much slower than before. This concludes post layout simulation of an inverter.